Okay, hear me out. I've been staring at the sky for what I can only describe as an emotionally exhausting amount of time, and I have a question. A big one. Why doesn't the moon just fall on us? Like, think about it, everything falls. You drop your phone, it falls. You trip over your own stubby little space boots, you fall. Apples fall. Potatoes definitely fall. Trust me, I have personal experience. So there's this giant rock just hanging out up there, and gravity is supposedly pulling on it constantly. So why hasn't it landed on my head yet? I used to think maybe the moon was just really good at balancing, like it found some cosmic shelf up there and it's just chilling. Or maybe there are invisible strings holding it in place, like one of those dramatic ceiling decorations at a party. I even wondered if the moon was scared of us, respectfully avoiding a collision out of pure courtesy. None of that is true, by the way. But here's the thing that really got me panicking. Gravity is real. It's not optional. It's not a suggestion. Earth is absolutely 100% pulling on the moon every single second of every single day. So if gravity is pulling the moon toward us and gravity always wins, shouldn't the moon eventually just arrive, like an uninvited guest who finally decides to stop hovering by the door and just walk into the living room? I brought this up to a scientist friend of mine and they laughed at me, which rude, but okay, let's talk about it. Here's the twist that broke my brain a little. The moon is falling right now as you read this. It has never stopped falling, not even once, not for a single moment since it formed billions of years ago. The moon is in a permanent, endless state of falling toward Earth. Wait, what? Yeah, let me explain, because this is where it gets good. Picture yourself throwing a ball. If you toss it gently, it arcs through the air and lands on the ground pretty quickly, right? Now imagine you could throw that ball harder and harder and harder still. The faster you throw it, the farther it travels before gravity pulls it down to the ground. At some point, if you threw it fast enough, something wild happens. The ball would travel so far sideways that by the time gravity pulled it down, the ground would have curved away underneath it, because remember, Earth is round. The ball would keep falling and falling, but the Earth would keep curving away from it at exactly the same rate. The ball would never actually hit the ground. It would just keep falling around the entire planet forever. That, my potato friends, is exactly what an orbit is. It's not the absence of falling. It is falling, just falling sideways fast enough that you keep missing the ground. The moon is doing precisely this. It's moving sideways around the Earth at a blistering speed, something like 3,700 kilometers per hour. At the exact same time, gravity is pulling it downward toward us. Those two things combine perfectly. The sideways motion means the moon travels far enough that Earth's surface curves away underneath it. So even though gravity is constantly yanking the moon toward Earth, the moon just keeps missing us. Forever. It is eternally falling and eternally missing. Think of it like running around a circular track while someone ties a rope from your waist to a pole in the center. The rope keeps pulling you inward toward the pole, but because you're also running forward, you never actually reach the pole. You just keep circling it. The pull inward and the motion forward combine into a stable loop. That's orbital motion in a nutshell. The moon is basically the world's most patient jogger, running laps around Earth's gravitational rope, never getting tired, never actually crashing. Now here's where my potato brain nearly short-circuited. This isn't just some special trick the moon does. This is literally how everything in orbit works. Satellites orbiting Earth, falling and missing. Earth orbiting the sun, also falling and missing, just on a much bigger scale. Every planet in the solar system is in a permanent state of falling toward the sun while moving sideways fast enough to keep missing it. The entire solar system is basically a beautifully choreographed dance of things falling and missing each other over and over for billions of years. So why did I even think the moon should crash into us in the first place? Honestly, it's because on Earth, we're used to seeing things fall straight down and stop. A dropped potato hits the floor because the floor is right there, close, solid, and not moving out of the way. But space doesn't work like that. There's no floor for the moon to hit, because Earth's curved surface is always sliding out from underneath it just fast enough. Here's a fun follow-up question. What would happen if the moon suddenly slowed down? Like, what if it just got sideways motion fatigue and stopped moving so fast? Well, if it slowed down enough, that perfect balance between falling and missing would break. Gravity would start to win. The moon's orbit would shrink, spiraling closer and closer to Earth over time. That is genuinely how some satellites eventually deorbit and burn up in the atmosphere. Not enough sideways speed to keep missing the planet. And what if the moon sped up dramatically instead? Same idea, but opposite. If it moved sideways fast enough, it could eventually escape Earth's gravitational grip entirely and drift off into space, never to return. So this whole system is a delicate balancing act, not a fixed lock. It requires exactly the right amount of sideways speed to counteract exactly the right amount of gravitational pull. Which raises an obvious question. Is the moon's orbit actually stable forever? Here's a wild fact for you. The moon is very slowly drifting away from Earth by about 3.8 centimeters every year. That's roughly the width of your average potato chip. This happens because of tidal interactions between Earth and the moon, tiny transfers of energy that push the moon a little farther out each year. It's incredibly slow and it won't affect us anytime soon, but over hundreds of millions of years, it adds up. Eventually, the moon will settle into a slightly larger, more stable orbit, and the whole falling and missing dance will just continue at a slightly bigger radius. So to bring this back down to Earth, pun fully intended, the moon isn't defying gravity and it's not balancing on some cosmic shelf, and it's definitely not being polite. It's falling, constantly, endlessly. It has been falling since the day it formed, and it will keep falling for as long as it exists. It just happens to be moving sideways at exactly the right speed to miss us every single time. Honestly, that might be the most oddly comforting fact I've learned all week. Every night when you look up at the moon, you're not looking at some static decoration hanging in the sky. You're watching an object in the middle of an active, continuous fall, one that has lasted for over 4 billion years and will likely continue for billions more. It's falling right now, past you, above you, around you, forever chasing the horizon and never quite catching it. So the next time someone tells you the moon is just sitting up there doing nothing, you tell them respectfully that they are wrong. The moon is one of the hardest working objects in the solar system. It's been falling non-stop since before there were potatoes, before there were astronauts, before there was anyone around to look up and ask why it hasn't landed yet. And now you know it's not going to. It's just going to keep gracefully, beautifully, endlessly missing. That's the universe for you. Some falls just don't end.